All right, guys. Particle motion is showing up on worksheet 73, so I wanted to kind of review a couple of things. The velocity and acceleration, a lot of it's review. You just don't understand that it's kind of review pieces. So when you're dealing with particle motion, use sign charts like we did in the first and second derivative test. If you guys remember, that would have been something like, well, if this is velocity, this would have been f prime, right? Because f prime is the same as velocity. If you use that, then we'd have like 2 and 3, let's say, and then we'd have positive, negative, positive. So we know that this part here, it's changing from a positive to a negative. So it's, according to this, a positive is moving right, and now it's moving left. Okay, so it's a change in position. Now it's moving left, and then at 4 seconds, it's now turning around to move right. So the idea is this, is that you're still going to do sign charts, except they mean something a little different. So a positive value is moving right, to the right. A negative value is moving to the left. And no movement is no change in position. So a 0, wherever it's a 0 at, like right here at 2, that's going from a positive to a negative, meaning the particle is moving to the right, and then at 2 seconds it stops, and it's going back the other way. Well, when it stops, at that given moment, there's absolutely no movement whatsoever. So that's where it would be 0, because velocity, or the f prime, is 0 right there. Remember, that's where our zeros are. We've taken the derivative and we set that equal to 0, and those are our zeros. So our zeros in velocity, there's no movement, no change in position. Don't confuse speed and velocity. Speed is velocity without direction. So when you deal with speed, if they ask you for the speed of something, just take the absolute value of velocity. Speed doesn't matter if it's moving left or right. Velocity does. So that's kind of the main thing about the idea behind speed. Acceleration, this is a little different. We'll work with this the next couple of weeks, but when it's accelerating, in other words, it's getting faster and faster and faster, the velocity and the acceleration, acceleration, don't forget, is the second derivative, are the same. Velocity and acceleration are the same. The particle is getting faster. So it doesn't matter if it's negative, negative. That means it's just speeding up to the left. If it's positive, positive, it's speeding up to the right. Okay, so when they're the same, the particle's speeding up. And when velocity and acceleration are different, the particle is slowing down. So if we had a velocity of positive and an acceleration of negative, remember, if f prime was positive and the f double prime was negative and the same interval, that means this is moving to the right and slowing down because they're different, okay? And then something like this would be moving left and slowing down. Crazy, huh? All right? So that's the idea behind the two, behind particle motion. So basically what we want is we want to understand that the non-derivative is our position. The velocity is our first derivative. Acceleration is our second derivative. We're going to use sign charts like we did for second and first derivative tests. Means a little different. Positive, moving right. Negative, moving left. 0 means there's no movement. And that means there's no change in position. There is a change in position. So even though we're dealing with velocity, it relates back to position. Acceleration will relate back to position if we need it to. But that's the real quick rundown on particle motion, and we'll do a lot more with it in the next week. Good luck, guys.